Hello, tonight our video is on applications of the Pythagorean theorem. So let's get started. Alright, so here we have a ladder, 13 feet long, that's leaning up against the wall, and a 90-degree angle is formed by the wall and the ground. And the wall is 12 feet high. So for here, we're figuring out how far away from the wall is the base of the ladder. Well, as always, let's start with our theorem. A squared plus b squared equals c squared. In this particular problem, 13, the length of the ladder, that's the hypotenuse of the right triangle that's formed. So that will go in place of c. And then a or b would be 12. So pick which one you want. Let's pick b. So we're going to let A represent the distance along the ground the base of the ladder is, away from the wall. So let's solve our theorem. 12 squared, of course, is 144. And then 13 squared is 169. Now notice, since we're solving for one of the legs of the right triangle, we will end up subtracting from both sides. So we get a squared equals 25. But that's not our final answer. Remember, a squared would represent the square that's formed by multiplying a times a. Since that area is 25, to find a, we would need to take the square root. So a is going to equal 5. And that's it. Okay, here we have a rectangle. And the diagonal of the rectangle connects the corners to form a right triangle. So the question is, what is the length of x? Well, again, we can see that the 30 and the 40 would be the sides of the two smaller squares that added together would equal the area of the large square. So that large square, its area would be x squared. Okay? So to find that, we're going to take 30 and square it, add 40 squared, and that would equal x squared. So you see, we don't always have to use a, b, and c, as long as we understand that in our theorem this would be a and this would be b, or vice versa, but this x would be c. Alright, so let's solve. This time we are going to add the areas together. We get 900 plus 1600 would equal the area x squared. So 2,500 is the area of the big square. So to find x, we would take the square root. So take the square root of 2,500. And then that, of course, would equal 50. So that diagonal distance is 50 yards. So how you doing? Is this making sense to you? Okay, here's an application to one of my favorite sports, baseball. Here we have a baseball diamond, and the catcher is situated at home plate, right here. And there's a base runner at first base who's trying to steal second base. So the base runner is going from first to second in that direction. So the question is, how far do you have to throw the ball to reach second base to get the runner out? So we're talking about this distance to second base. Well, that distance would represent the hypotenuse of a right triangle, because the distance from home to first base would be one leg, and the distance from first to second base would be the other leg. All right, so the picture would look something like this. Here's the catcher over here, right? The distance to first base is 90 feet. The distance from first to second is 90 feet. So the question is, how far would the catcher have to throw the ball to get the runner out? And so that distance is the hypotenuse of a right triangle. So we're going to take 90 and square it. And then 90 and square it. Add those together, that would equal the distance. Let's just call it x this time. That would equal the distance squared. So 90 squared is 8,100. So adding those two together, we get 16,200 is equal to x squared. All right, so to find out x, we would have to take the square root. Now the square root of 16,200 is not a perfect square. It is an irrational number, so this is going to be an approximate distance. And it comes out to approximately 127 feet, if we just leave it as a whole number. All right, so how'd you do on that? That makes sense? All right, one more problem to go. Here we have a situation where Sam is riding his bike to school each day. And when he leaves his house, he rides 6/10 of a mile east. Then he turns left and rides 8/10 of a mile north to the school parking lot. So the question is, how far is his house from the school? All right, so here we have a diagram of directions. Remember, on a piece of paper, north is always up, south is down, west would be to the left, and east to the right. So let's say that this is Sam's house right here, and it says he rides 6/10 of a mile east. So that's going to be this direction. Then he's going to turn left and ride 8/10 of a mile north. That would be this direction, up. And the question is, how far is his house from the school? So in other words, if he could just ride in a straight line right to school, if there was nothing in the way, how far is the house? So we're talking about this distance right there. So again, when you turn from east and head north, you are making a 90-degree turn. So this is a right triangle. Pause your video, solve for the distance, restart to check your answer. Welcome back from pausing the video. 6/10 and 8/10 are the legs of the right triangle. And the distance from Sam's house to the school is the hypotenuse, so we'll call that C this time. And let's solve for C. So 0.6 squared would be 0.36. 0.8 squared is 0.64. If you add those together, 0.36 plus 0.64, you get 1.0. All right, now we'll take the square root. Well, the square root of 1 is just 1, because 1 is a perfect square. So Sam's house is 1 mile from the school. However, because of the way the streets are laid out, he has to ride actually 1.4 miles to get there. So how'd you do? Well, that's all for tonight. Remember, read some books.